Today we're taking a look at sections 5-1 and 5-2 on random variables. Our goal in chapter 5 is to create a theoretical model describing how the experiment is expected to behave and then get its parameters. So what we're working with in both chapters 5 and 6 will be random variables. A random variable is a variable which is usually x that has a single numerical value determined by chance for each outcome of a procedure. A probability distribution is a graph, a table, or a formula that gives the probability for each value of the random variable. Requirements for a probability distribution are, get my pen working here. That should be a period here. The requirements for a probability distribution are, first of all, the sum of all the probabilities P of x should equal 1, where x assumes all possible values of the random variable. Second of all, each individual probability P of x has to be a number between 0 and 1 inclusive. Now, we have two formulas, one for calculating the mean and the other for calculating the standard deviation of the probability distribution. And notice in the second one, the radical goes all the way out there. Okay, to find the mean, we take the sum of the x, each individual value of the random variable, times the probability of that value occurring. So we multiply all those products and then add them up. For the standard deviation, we take the square root of the sum of x squared times each of the probabilities minus the square of the mean. And we'll be doing these with tables. Rounding rule results round results to one more decimal place than the number of decimal places in the random variable x. And again, we want to reiterate unusual values from the range rule of thumb. The maximum usual value is mu plus 2 times the standard deviation, and the minimum usual value is mu minus 2 times the standard deviation. Unusual results, an unusually high result is when x successes among n trials gives us a probability of x or more that is less than or equal to 0.05. It's unusually low when the probability of x or fewer is less than or equal to 0.05. So again, with probabilities, the unusual is identified with the division at 0.05. Expected value is another word that's used in place of the mean. It has exactly the same formula as the mean. The expected value is the sum of all of each individual value of the random variable times its probability. Okay, so make sure you watch the sample problems.